So I'll talk about multiple zeros of a polynomial and what happens to the graphs of polynomials at those zeros. So here I have this function. It's a polynomial in completely factored form. The zeros of it are 3, 1, and -3 because those are the three values that make the function equal to 0. X equals 3 is coming from this factor, which has power of 2. So that means that 3 is a zero of f with multiplicity 2. One is a zero because of this term, and the power of that is 1, so 1 is a zero of multiplicity 1. Finally, -3 is a zero because of this term, which has a power of 3. So -3 is a zero of multiplicity 3. Okay, let's take a look at the graph of f at these zeros. I've shown it right here. The window used is x min is -10, x max is 10, x scale is 1, y min is -1000, y max is 1000, and the y scale is 10. This way we can see the nice behavior. Okay, here is the zero of 3, okay, which is located right here. Notice how the graph bounces off the x-axis at that 0. Then the 0 at 1. 1 is located right here. Notice, okay, and 1 has a multiplicity of 1. Notice how the graph pierces the x-axis here. At the 0 of -3, which is right here, the graph also pierces the x-axis, namely it goes through it, but it curves a little bit. Let's look at another graph. So for this function here, the zeros are 1, 5, and -2. And here are the multiplicities. So the 0 of 1 has multiplicity 4, 5 has multiplicity 3, -2 has multiplicity 5. So let's take a look at the 0 at -2. It's right here. We see that the graph pierces the x-axis, but it starts to flatten out a little bit right there on the x-axis. Then at the 0 of 1, the graph bounces off the x-axis, starts to flatten out a little bit. At the 0 of 5, the graph pierces through the x-axis, but it's a little less flat than at the 0 of -2, which had multiplicity 5. Okay, the two graphs that we just looked at sort of give us an illustration of a behavior in general of functions with multiple zeros. Let's talk about that now. So if the 0 has odd multiplicity, then the graph pierces the x-axis at the 0. But you see here, as the degree or the value of the multiplicity increases, the flatter the graph becomes. Okay, so here's y equals x cubed, y equals x to the 5th, and so on. It becomes flatter. If a 0 has an even multiplicity, then the graph bounces off the x-axis. And yet again, as the value of the multiplicity grows, the flatter the graph becomes at the point where it bounces.